If you've worked much with exponents before, you probably know that if we were to look at something like x to the fourth divided by x, a shortcut to allow us to simplify this would be to simply take our exponents, the exponent 4 in the numerator and the exponent 1 in the denominator, and subtract them, and get that our answer, or the simplified form of this, would be x to the third power. Now, if we were to have something like x to the fifth divided by x to the seventh. Well, if you use that same property, the idea, or the shortcut, that if we take our exponents and subtract them, we would get that our answer is x to the negative 2 power, because 5 minus 7 would give us negative 2. Now, what does that negative exponent really mean? Well, another way to look at this is to go back to the idea of expanding. Let's take a close look at what we really have. Well, we have x to the fifth, so that's 1, 2, 3, 4, 5 x's in the numerator, and we have 7 x's in the denominator, x to the 7th. So 1, 2, 3, 4, 5, 6, 7. Now, if we look for common factors, because when we have fractions we can do that, common factors between the numerator and the denominator, we've got common factors of x, another set, and if we divide out all those common factors, we are left with these 2 x's. But if you look carefully, you notice that they're left in the denominator. So we really have 1 over x squared. So according to our exponent rules, the answer to this is x to the negative 2 power. But if we expand, we get the answer 1 over x squared. Now, in math, we have something that's called the transitive property. The transitive property simply tells us that if we have 2 different things that are the answer to one particular question, then those 2 different things must themselves be equal. So we're simply saying that x to the negative 2 has to be equal to 1 over x squared. Now, what's the relationship between these 2 things? These 2 are what are known as reciprocals. A reciprocal, in easy terms, is simply taking your numerator and your denominator and flipping them. X to the negative 2 has the numerator, the base is x, the denominator is 1. If you take that and flip it, put the denominator into the numerator, and then take the x and put it in the denominator, we get 1 over x squared. These 2 things have to be equivalent. Let's look at another example that's very similar. Say we were to take x to the third and divide that by x to the sixth. Well, according to our exponent rules, that shortcut that says if we take our exponents and subtract them, we get x to the negative third power. 3 minus 6 is negative 3. If we were to take this same thing and expand it, we would have x times x in the numerator, and we would have x times x times x times x times x times x in the denominator. While looking for our common factors to divide out, we have 3 pairs of common factors that divide out, and it leaves us with 1 over x to the third. Now, since these 2 things came from the same initial question, that tells us that x to the negative third has to be equal to 1 over x to the third. And again, these 2 things are what are called reciprocals. So what we have is the idea that a negative exponent by definition means the reciprocal of the base. Now remember, the base is that number that's being raised to a power. So if we were to take this definition, that means that x to the negative 7th power would simply be 1 over x to the 7th. 2 to the negative 3rd power would simply be 1 over 2 to the 3rd. It even works if you start off with a fraction. If you have 3 over 4 to the negative 2 power, well, the reciprocal of that base, the base there is 3/4, the reciprocal of that would be 4/3 to the 2nd power. Simply stated, a negative exponent means the reciprocal of the base.